With this one, I'm coming to show you how to set up your scope, or maybe your scope or your device, and I'm using the tool to do the injection. So with this one, what I'll do is, this is the voltage being measured. So to set up your scope for this kind of project, first you have to know the kind of voltage you are measuring and how to set the scope up for it. So now I know I'm measuring 11.8 volts, which is the battery voltage here. That's the battery voltage, 11.8. So I know I am measuring 11.8 volts here. So what I'll do now is, now I have to set up my scope to handle 11.8 volts, and with this one I'm measuring an injector pulses. So I have two options. It's either I'm going to use an attenuator to step down the voltage, or I'm going to set the voltage such a way that it will get to the screen, because it can spark up to, let's say, 60 volts or 30 volts. So if you can see with this unit, always you can see that there is square boxes, which is the voltage. So this vertical line is the voltage, and this horizontal line is the time. So with this one, I want to measure, let's say, a voltage around 60 volts, and my scope, I can set it up to, now I have set the scope up to 1 volt per division. So you can see that you can't see any measurement on the line. And this same thing, that's the same thing as this Owen scope. So what I'll do now is, I'll just count it. I'm measuring 11 volts on my multimeter. I'm measuring 11 volts on my multimeter, and I'm coming to measure the voltage here also. So now what I'll do is, I have to increase the voltage. So we can see on the O-ring I've set it to 2 volts per division. So that means 1, 2, 3, 4. That's 8 volts that I can measure. But let me click on this one and bring you can see my channel 1. I will bring it down so that I can be able to measure more voltage. So when I bring it down, you can see that now my yellow line begins to show. So let me bring it down, and now you can see I'm getting the exact voltage that my multimeter is measuring. So the exact voltage that my multimeter is measuring is 11.9, and when you come here, when you come on this one, you can't see the 11.9 because it is out of range, so it can't measure it. But now that I've set this one, you can see I'm measuring 11.8 on this. So what I'll do now is, I have to change the voltage. So I know I'm coming to measure an injector pulses. So I'm coming to measure an injector pulses, and you can see the setup. So after that, I'll connect I'll connect this one also, the arm clamp also, and measure the current flowing through an injector without fluid pressure or anything. So this is the port injector which I'm coming to measure. So now what I'll do is, let me use my, wow, the injector keeps heating up because there is constant voltage flowing through, which is the 12 volt voltage flowing through. So now what I'll do is, let me set it up first before I connect the injector. So because I've connected to this circuit, now the injector is very hot. So let me set it up. Let me go to injector pulses, then select, then click on it. So it means I should be measuring an RPM of 3.0 milliseconds. So what I'm coming to do now is, I'm measuring a voltage around, let's say, 12 volts, which can spark up to 15 volts. And because of the injector, that's why the voltage was dropped. So you can see when I disconnected the injector, now I'm having 12.3 volts. So what I'm coming to do now is I'm coming to set up this scope to measure the injectors. So now what I'll do is I have to change the voltage to 10 volts per division. So now that means every square is 10 volts, every square is 10 volts. So let me push this one up a bit. Let me push it up a bit, up to this point, because the voltage will only drop. So now what I'm going to do is, because I'm measuring voltage on it, let me turn on my scope. It just went off. So now what I'm going to do is I've set this one up ready to measure injector pulses. But the thing is, I'm measuring an injector pulse with 3.0 milliseconds. So that means when I come here, I have to change my time base to around 10 milliseconds to get the picture on the screen. So now my time is in 100 microseconds and I'm not going to change it. So let me set this one also up to be able to measure the injector. So this one also, let me go to channel, press on the channel, then change the voltage to 10 volts per division. So now you can see I'm measuring it. So 10 volts per division, and let me bring the line down a bit so that it could be in the same. And now the only thing is, this one also, I'm having 5 milliseconds. So this one could get the injector pulses. This one could not get it because the seconds. So let me not talk too much. Let's start the injector pulses. So let me start the injector pulses. So click on OK, and now you can see the blue mark which tells me that the injector pulses has started. So let me connect my injector. The moment I connect the injector, I'm coming. What I've done is, you can see my waveform has turned, and you can see I'm not getting any waveform on this because of what I said. I told you the time base. So with this one, what I'm going to do is I'm going to increase the time base, and you can hear the injector pulsing. So what I'm going to do is I'm going to time, then increase the time base. So let me increase the time base, and you can see now I'm at 1 microsecond. So let me take you close for you to see what I'm saying. Yeah, I'm at 1 millisecond, and let me change it again. Let me increase it to 5, and you can see at 5 hours at this, I'm getting it on because of the time base. I'm getting it on because of the trigger. This one I've not set the trigger. The trigger is way above. So let me set this one, or this trigger also down. And the moment I set this trigger down, you can see now it has also stopped at a point. So now what I'm going to do is, you can see it looks like my scope has turned upside down. So let me work on that also and see if I'll get it back. So now I've set it right, and you can see the injector pulses. So what I'm going to do now is, the injector is working now, and let me check the current also. But for the current, the only thing I can do is I can only measure it on one scope. So let me choose one of the scopes. So let me measure it on this. So let me measure it on this. Let me turn on, or let me set up the scope. So now let me go and clamp on the black wire. So I've set my arm clamp on the black wire. Then what I'll do now is, now I've set the current on this one. So let me turn on channel 2. So let me go to switch on and off. Let me tap on it again to move to channel 2. Then let me switch it on, select DC. Then I have to reduce the voltage on channel 2 because the voltage I'll be measuring is very low. So you can see the current that I'm getting. So let me push it up a bit, and you can see with this one I'm measuring the current. And now what I'm going to do is, you can see my current as 10. So let me zero it out and turn my amp clamp again to get the waveform correct. There is too much noise in this line. There's too much noise in it. So let me go to this one also, and it's the same thing. So there's too much noise in it. So what I'm going to do now, or what I can do now is, let me isolate it a bit, or let me change it there. So you can see my current now. You can see that my current on the here. You can see my current on the injector. So now what I'll do is, you can see now I'm able to, so let me change the time base here, and let me send it to, so when I change it to, so you can see we are measuring 2 milliseconds, 3 milliseconds as the pulses is saying here. So what I'm going to do is, I'm going to try the scope on this one also. So let me touch it with it and see if I'll get any. I'm not getting it because of the ground. So let me find for ground for it. So you can see that there's too much noise. So I'll change my amp clamp, I'll take it out and I'll work on it. So that's how you set your scope up. So this one, when I go and reduce the time base, you can see it also increases. So 1 millisecond, you can see one. So you can see I'm able to read on this, and I think they have trigger on this. Yeah, let me go to positive because they have trigger on this, so you can trigger the injector pulses. So you can see this one I'm doing 2 milliseconds, and this one I'm doing 2 milliseconds, this one I'm doing 1 milliseconds, and you can see the sizes are different. You can see this one is larger than this. So the time is used to expand the waveform that you are looking at, and the voltage is used to like contract or open it too. So if you want to zoom out, you use the time. If you want to lower it or get it bigger, you use the time base. You use the voltage to do that. So this is an ignition pulses. This is an injector pulses for a port injection. So what I'll do now is, let me disconnect this one and also set it up on the laptop using the Oscilloscope. Which they stopped producing. So now let me connect it to this Oscilloscope. So now I've disconnected one and I've connected my Oscilloscope. So what I'm going to do is, I'm going to set it up on the Oscilloscope also. So with this one also, what you do is you go to auto for it to find the device, and the device is in. And I'm measuring 12 volts. You can see the kind of waveform I'm getting. This is not what I want. So on channel 1, I can come to this side. It's measuring in millivolts, and I want, so I can select the voltage, which is 20 volts per division or 50 volts. Like for this one, the volt is for the whole screen. So if I select 20 volts, then yeah, everything is okay. So the next thing for me to do is to change my time base. So come here and change my time base to 2 milliseconds, and you can see 2 milliseconds. you are able to find it. So let me check my scope connection properly. So let me select 20. So let me do the injection pulses properly. I can't do auto, so let me select 250. So let me see my trigger. Okay, let me do a higher time and see what I'll get. So setting it up, let me do 100 milliseconds and see. Okay, I'm getting this, and let me do trigger. Let me set my trigger. So this is the pulses that I'm seeing. Wow, I think there is a problem with this scope, because let me change the channel also and see if I'll find any improvement. So let me go to channel C. So I'm using channel C, and channel C auto detect and DC. Let me select 20 volts. Then let me change my time base to 10 milliseconds. And let me click on trigger. So auto. So this is my trigger. Let me pull it up a bit and see if I'm going to see any voltage so far. Why am I not getting anything? Oh, let me check my. Oh. Okay, so I've rectified the issue. It was the cable which was having a connection issue. So now that it has been rectified, now let me set my trigger up a bit to get it on point, and let me change the time base. So let me change the time base to to 10, 5. Okay, so let me try. Okay, so the trigger is on A. So let me take it out and place it in A. Then you can see now A is at 5 volts, and you can see now I'm getting the connection on it. So what I'm going to do now is, you can see I'm getting, so when I increase the time to 2, I'll get it to expand. And when I change the voltage from 10 to 5, it will change. You can see it has occupied the whole screen. So when I change it from 5 to 10 and change it from 10 to 20, so that means the whole screen is what we are getting, the 5 volts. So let me go to 20. Oh. Let me set it to 20, and 20 you can see, so the whole screen is the 20, 10, and let me go up a bit too. So it was the cable which was causing the whole issue. So the whole screen is what we are getting, the 50. So 25 down, 25 up. So that's how it is. So you can see it is starting from 0 here and 25 up, 25 down. So now what we are going to measure next will be an injector pulse, direct injector. So this is for current injector, and my arm clamp battery is there, so I have to replace it. So now, okay, let me replace it, and let's connect this one also. So now I've connected my arm clamp to it, and to set it up I have to select, so I have to go to tool and select this one and select current. So the probe I'm using is an arm clamp, which is this. So it's going to set it up. You have to zero the arm clamp. So let me set the arm clamp up. What I've done is I've set the arm clamp here to test if it is working, and it is working. And with this arm clamp, I've set it to 1 millivolt is equals to 100 amps. So let me measure the voltage here, and the trigger is on point. So let's say we are measuring around 6.7 millivolts. So what you do is 7.2 milliseconds. So sorry, 7.6 milliseconds. So what you do is you multiply it by 100, which you are going to get the exact voltage. So now let me connect it to the channel C and see if it will come on it. So this is the current, and you can see the amp, which tells me that the injector is good. Although there is no fluid in it, I'm able to get that amp. So let me put it on the bigger one and see, and set it up properly. So now it is connected to the auto, and let me set it up properly. So now I'm able to set it up, and I have the exact. So now let's do the calculation and see if it is going to match up. Let me pull my time. No, let me pull the rule and measure it. No, let me pull the rule and measure it and see if it is the same as we measured. So now after doing it, you can see we are measuring about amp of it's around 4 amps. So it's around 4 amps as we place it here. It's around 4 amps, but it's subtracting it from this, so it's almost 3.7 amps. That's what this is draining. So what I'll do next is we are about to measure an injector, a direct injector. So this is the waveform you get for. So what you can also do again is, let me go back, let me go to the function and change the RPM also. So you can see. So now you can see that even with this one you can get the amp here. So you can see you get the amp here before it opens and the flat top. So I'm reducing the RPM, which is related to frequency. So the RPM, when I'm reducing the time base, you can see whenever I'm reducing the time base, the waveform begins to get closer and smaller, and now it is at 1 milliseconds, and you can see it has affected the waveform. So now let me give it an extension of which this injectors run around 2.5 to 3, and even some go to up to 4. So you can see the more I'm increasing the time, the more the waveform begins to. So 2, so 3. So now let me decrease the RPM. So when I decrease the RPM, you can see the effect on the injector. You can hear that it's running very slow, opening very slow, and it's not really affecting the waveform that much. But I see something, I'm coming to increase the RPM. which is related to what we call frequency. So now it's running very fast, and you can see the RPM, which means the opening and closing of the injectors are very fast, but because of the time base, which is constant, so it doesn't move on the screen. And you can see here also, so you can see it's the opening and closing of the injector. So it's like any other solenoid. I can even change the injector and do it a solenoid, and you can see the RPM is around 3000 RPM. So let's try and measure. Let's try and measure the injector, the direct injector also. So set it to 1000 and set up for direct injector. So give me a minute. So let's do a setup for direct injector also, and we can see the voltage that we are measuring also here. So we can't measure any correct voltage because the refresh rate of the voltmeter is very low. Thank you for watching. Subscribe to my channel for more videos. So I'm done with the setting up. So this is a direct injector for Honda Pilot. So this is a direct injector, and now let me click on the start button, which is okay. So when I click on it, I should be having an RPM, and you can see the injector pulses is a bit different because the same wire, which is this same wire, but just that the pulses is from the control unit, and this, so I take this as my control unit, which is controlling the pulses. So this is the kind of setup it has been made to pulse the injector. But normally a correct direct injector waveform doesn't look this way, and you can see measuring the port injector, the waveform was a bit different from this, and you can see this, the current has gone way high. So now this is taking in more current. This is taking in more current. The direct injector is taking in more current than the port injector. So now what I'll do is, let me set my amperage properly, 10 amps. Okay, so now I think this. Yeah. So this is the amps that I'm measuring, and you can see the amps 1, 2, then it goes up. And for direct injector, normally it runs within 1 microsecond. So let me try and change it to the time actually the injectors run, and you can see as I'm changing it, it's reducing the current. It's reducing the current. The time base is reducing the current. So if I increase the time base, it increases the current that the injector is drawing or is being. So because it is opening for long, and these direct injectors do not open for that long, so they open around 0.9 milliseconds or maybe 1 milliseconds. That's the range at which they operate. So if I set it around that point, you can see if I take it to 8, it is almost like the current, which was around 4 amps, which the port injector draws. So you can see there is the waveform for a port injector. The direct injector look a bit different than this. So this is how you get it. So let me take this one also to the okay, so you can see this one also. I'm having my waveform. Let me change the voltage, and you can see the voltage also. So with this one, when you want to change the voltage, it is up and down, and you want to change the time, it is left and right, because it is used for zooming in and zooming out, and the time is used for expanding. So you can see the injectors are running perfectly. So they all work under the same principle. The reason why it is clicking this way, when I put a relay to click the same thing, when I put any solenoid, I'm coming. I have I have a solenoid there. Let me put that solenoid also. Let me fit that solenoid also, and let's see if the waveform will change or we will get the same waveform. So also with this one also, you can see we are getting the same pulses. And let me increase. We are getting the same waveform, which means that's the same waveform that this machine is designed to produce. So it's designed to close and open solenoids or injectors or anything. So let me increase the time base, and you can see my waveform is changing. And I've connected this solenoid, and you can't hear it, but when I hold it, I can feel it clicking. And you can see the current that it is drawing. So it is taking in less current, and you can see it's up a bit. So let me place it on the table for you to hear. So when I press it to the table, you can hear the clicking noise. So this is how this device is designed to be used. So you can use it to test any solenoid that you want, depending the current is not really higher. So I brought a patch valve also for us to test and see if you're able to get this waveform. That means you are testing it right. So let me pause it and swap the solenoid. I've connected the patch valve. This is the patch solenoid, and this is the start, and you can see I'm getting this waveform again, and when it comes here I'm getting the same waveform, but just that the current is low. And so this is the opening time and the closing time. So let me increase it to open more, let's say maybe 5 milliseconds. Set it to 5 milliseconds. So now it's set to 5 milliseconds, and let me reduce the RPM, and you can see on it that you can see that. Let me reduce the RPM also, and it's up to 500, and you can see the RPM is up to 500. The RPM is up to 500. So let me, and just clicking, but very slow and dull. Wow. So it is working, but very slow. So you can use this device to test any solenoid, and you are still going to get this waveform. So let me increase the RPM. And this solenoid is not designed to be opening and closing at a fast rate. So thank you for watching. Subscribe to my channel for more videos, and we will set up a donation so that we can build up a lab for ourselves, a lab to train others. Okay, so now what I'm going to do is I'm going to set up this device with what we call signal lines. So it sends signal output. So let me measure. So with this signal output, they have the sine signal, they have the cos1 sine, and they have S1 and S2. So what I'm going to do is I'm going to try and measure the sine signals. So let me connect this. So what you have to do is you have to get ground, and there is ground on this line already. So they've written ground on it. So you select the ground to connect to your scope if you want to measure the signal lines. So let me connect my ground to the scope. Let me see. Connect my ground to the scope. Let me change the pin out here. So now that I've connected my ground to the scope, let me find for this yellow extension, and let's start from the sine signal. So we start from the sine signal, which is this one. and let's see the kind of waveform that we are going to get. Now we don't know the waveform that we are measuring, but from the look of instructions it tells us the waveform we should expect and everything. And yeah, and how it works and everything. So it sends 100, I think 10k hertz and 5k hertz and 5 volt, and also you can control the duty cycle. So let me click on OK to continue, and you can see the frequency, the duty cycle, and when you press OK it begins to. So this one will help you to set up your scope whenever you want to set up a scope to read signal. So we use this for a training purpose because we want to set up a we want to send signal to a control unit or to a unit. So let me connect my red signal line, then let me press on OK. So on the OK you can see my signal line is being read, but you can see the waveform that I'm getting, which is the sine wave, and you can see from here also the waveform I'm getting. When it comes to sine wave doesn't have anything to do with duty cycle. So here I'm going to change my voltage to get the exact screen that I want, or how I want my waveform to be seen on the screen. So before that, let me shut the channel 2 off, and let me decrease my voltage. So you can see that now it is at 10 volts per division. So now let me decrease the voltage to, let's say, 2 volts per division is okay. So what I'll do now is I'll push my waveform up, and you can see the waveform that I'm getting. So it's measuring max of positive 2.3 and negative 2.3, and I can change the hertz, which is the frequency. So this is 1k hertz or 1000 hertz. So with this frequency it affects the waveform, and you can see also it affects the waveform here. So if I want to do anything, I have to change my settings to, let's say, 2 volts per division, and it has covered the whole screen. So let me change it to, so this one you will select this 2 volts per the whole screen. So let me go to 10, and you can see we are having a decent waveform. So let me disconnect it from this part and send it to this scope, so that we'll be using those two scopes to run our class for today. So you can see on my scope the waveform is really bad. Let me turn on my multimeter and see if I'm able to read anything. And you can see on my multimeter I'm reading 0.6 millivolts, right? And let me swap it to AC volt. You can see the fitting DC and now AC, and you can see I'm getting the hertz, so which is the frequency. So you can see I'm getting 1.5 volts, which is averaging it, because this shouldn't happen, which is averaging it. So let me see the same thing I'm measuring here. Let me switch this to this TRMS for waveform. So when it comes to sine wave is solely for DC, for AC. So let me switch my multimeter leads to this point and see the voltage I'll be measuring. It's the same voltage we are measuring here. So I'll leave it that way. And you can see that let me go to scope, and you can see on this scope I'm getting it messed up. I don't want to do auto, and I know my voltage is around 2.5 minus and 2.5 negative, because it's a sine wave, and that's how sine wave behaves. So let me set my volt. You can see my voltage here is in 10 millivolts. So let me go to channel and reduce it. So let me increase my voltage. So to here we set it to 2 volts per division. So here we can set it to 2 volts, and I push it into the middle. So you can see this device, say I'm measuring this. So anytime you are measuring a sine wave, it depends on the sine wave that you want. So this sine wave, you can see how you are measuring it. So it's between 2.3 positive and 2.3 negative. So you can see the voltage here. And when you come to this side also, you can see the minimax is the same as the other side, and you can see the frequency is around 100, and you can see it also here, the frequency is correct, but just that the voltage is different, and here to the same frequency as the other side. So what I'm about to do now is, you see, when it comes to sine wave, it doesn't have anything to do with duty cycle. So let me change the duty cycle, and you see it will not affect the sine wave. So you can see when it comes to sine wave, there is no duty cycle effect in it, and you can see my duty cycle is at 6. It doesn't affect it. The only thing that affects sine wave is frequency. So let me change the frequency, and you can see the frequency it affects it. You can see it is closing up because I'm changing the frequency, and when I change here, you can see the frequency that we are measuring now. We are measuring 2.5K, and when you come here, it's also 2.5K, and we set here is 2.5K, and when you check it here also, so you check it here also, is 2.5K. So you can see the only thing that affects a sine wave is the frequency. Duty cycle doesn't affect sine wave. It only affects square waves. So from here we'll go to square wave, but I have another duty cycle waveform wave to show you, which this machine generates. So this is a signal generator also. So let me set it up also for that signal generation. So now we are going to cos1. Cos1 is the S1 is also signal, is a waveform generator. So you can see here, you can see that this scope is reading it a bit different because of the trigger. So let me go to trigger and push my trigger up a bit, and you can see because of my trigger, so you could see the waveform moving. And this one is also stable because the trigger is already set. So you can see we are getting a waveform, but this waveform that we are getting is a sine wave, but it's a sine wave from 0 to, let's say 0 to, let me measure it here. So when I check this one, 0 to 4.9, which is 5 volts that you can send to any unit. So this one also is 0.5, and it is a sine wave. But you see, because it's a sine wave, and we are measuring only the voltage, and we are not getting the frequency here. But when you come here, you see you can get the frequency. So let me increase the frequency, and you can see they are closing up. So when I increase the frequency, you can see they are closing up, and they are not affected by any. So you can see I'm now changing the duty cycle, and it's not affecting them. Duty cycle is not affecting them. The only thing that affects them is the sine wave. So this one also is a sine wave, but this sine wave is 0 to 4.6 or 4.7. And let me switch this to DC and see. When I switch it to DC, you can see we are measuring average of it. So which is when it's being divided by 2, we are measuring the average of it. So with this one, what I'll do next is I'm going to switch to the square wave. Now we are done with the sine wave, which is this S1. So now let's go to S2, which is the square wave. So now let's plug in and set up our scope. But for this, let me see the voltage we'll be getting, because we've plugged in a battery voltage. So let me see. Okay, so now after plugging it in, you can see we are getting it to fill the screen. So I've taught you how to set up the scope already. So with this one, when it is filling the screen like this, you can either adjust, depending on the scope you are using, you can either adjust your voltage. So now let me adjust the voltage, because I know this volt is supposed to be around 12 volts. So let me adjust the voltage. Let me set my voltage to 5 volts per division. So let me set it to 5 volts per division, and you can see the effect. So that's a 5 volts per division, and because of this trigger, that's why you can see it to be stable. When I bring the trigger down, you can see it is moving. It is not stable, but because of the trigger, so trigger is used to pause or stop the screen. So when you see it like this, it's sending the signal, but because of the trigger, so it's stable now for you to see. And this side also, what I'm going to do is go to channel. I click on channel and change the voltage, increase the voltage, and now to 5 volts. So you can see, so when it comes to square wave, it's being affected by duty cycle. So now let me change the time base for the waveform to be big a bit. So it is 1 milliseconds. So let me reduce it to, okay, so 200 microseconds. Let me reduce this also to 200. Let me reduce this also. Let me click on, so anytime you want to set your time, that is the HRO. So let me go to the time and reduce it, and reduce the time to, so this one is set to 200 microseconds. This one also is set to 200 microseconds, because I want you to get a view of a full cycle. So when we say a full cycle, that means starting from here and ending here. That's a full cycle. So these duty cycles means the off and on time. So it is off 50% and it is on 50%, and that's what the waveform is displaying here. So you can see the duty cycle, it is off 50% and it is on 50%. So that's what you are seeing here. So now what I'm coming to do is I'm coming to change the I'm coming to change the duty cycle on this. So let's monitor. Let me bring you back. Let's monitor the duty cycle. As I'm changing it, you can see the voltage on the meter also will be changing. So you can see when I'm increasing the duty cycle, you can see the on time is very small. The on time is very big than the off time, as I told you. So when we say square wave or digital signal, so you can see the on time and the off time. So it has turned on 82% and it has off for the rest of it for it to be 20. So which is up to 18%. So 18% off, 82% on. So you can see the voltage also that I'm getting. I'm getting a voltage close to the 12 volts. So let's set it to, let me reduce the frequency. Let's set it to 99. That's what we are going to get. So 99 is going to give us equivalent voltage to the battery voltage. So 99 is like we are off on 1% and 99% on, off 1% and 99% off, and you can see we are getting equivalent to battery voltage. So this tells you more about the square wave that we talk about. So normally square waves are being affected by duty cycle, and also it's being affected by duty cycle, and also it is being affected by frequency. So with this off time and on time, the frequency will also affect the appearance. So you can see when you give yourself like 200 milliseconds, you can see that it is turning on. Let me increase the frequency from 1 kilohertz to 1.5 kilohertz to 2 kilohertz. You can see now you are seeing more legs in. So now let me reduce the duty cycle also to 0, and let's see, which if I reduce it to 0, that means I'm turning it on 90. I'm turning it 0%, so it's almost up to 1%. So you can see the whole signal is really off now, and you can see the voltage that I'm measuring millivolts. I'm not measuring any voltage at this point, and even the frequency is not being affected. So now what I'll do is let me increase the, so now that I'm increasing the duty cycle, you can see now, let me set it up to 50 again. So now it is at 50 now, and you can see it's at 50, and now the voltage is being divided by 2. So thank you for watching. Subscribe to my channel for more video. So we do more work on this. So I'll teach you how to use this square wave also when you are working with it. Now I don't have my test light here, like I'll connect a test light to it, because test light draws in less current, which you will see the effect on the duty cycle. It looks like my scope is running out of battery. I'll plug in the charger just now, then we will continue the video. So you can see when it comes to scope, it's not that much difficult depending on your perspective on it. So you can see with this one, the waveform, so it's all about you knowing what you are measuring. So now you are measuring total of 12.4 12.6 volts, right? And this one also gives us the same thing, and we are measuring 2.5 kilohertz, which is the frequency, the number of time it is appearing. So this is my little setup, or my little lab that I've set up. So let me try and see if I can get my test light so that we use it and see the duty cycle also. And also let me try and power it up. So I tested something, and I want us to share this thing. So this waveform is a signal waveform. So it's not something that you can test with power or anything. So I'll connect this my test light to battery ground and touch the signal line and see what will happen. If it goes down, my test light is safe to be used because it carries only 100.1 or 100 and something milliamps. So you can see when I touch it with it, the whole waveform goes out. This tells me that it is a signal line, so you can inject it into a control unit whenever you want a signal or you want to read something. Maybe in future I'll do that. Maybe I want a signal that I want to send signal to a unit to check and see if that unit is, or that signal line is working properly. So you can see when I touch it, it goes off. So now let me take it to battery positive and touch it again. The moment I touch it, you see it doesn't go off, it stays on because it's already at the same voltage of the battery, which is 12 volts. So it's not affecting the waveform. But the moment I take it to ground and I touch it, it affects the waveform. You can see the waveform is being grounded. So let me touch it from this side also, and you can see my test light is even turning on. So see what's happening to my test light. It's even turning on because you can see when I bring it to this side, it turns on because this is the ground side. So my test light is being grounded, and this is the signal side, which is being, even when I touch it, it makes the waveform look okay. So you can see my waveform turns on. So one lesson you learn in this is anytime you short a signal line to ground, it will ground it to 0, as we see it on the scope. Thank you for watching. Subscribe to my channel for more videos. With this device, you can see my waveform is deformed now because the waveform is deformed because when you disconnect the battery voltage from this, whenever you disconnect it from the battery, it gives a different voltage. So now let me set up my scope properly. I'm doing 5 volts per division, so let me change my voltage, go to channel and change my voltage to, let's say, 1. Okay, then change this voltage also. So go to switch and change my voltage to 1. Okay, you can see it's reading abnormal, so let me do my trigger properly to get it reading properly. So now you can see the way the waveform is reading, and I'm measuring up to 2.5 volt and also 2.5 volts here. And let me check on my you can see I'm measuring 1.3 1.8. so this is a line that you can use to check signal 5 volt signals like injector pressure sensors. So injector pressure sensor is direct or indirect port injection. You can use it to check. So when you connect it, so the moment I connect the battery, you can see my voltage goes up. When I disconnect it, it comes down. Thank you for watching. Subscribe to my channel for more videos. With this device, you can see my waveform is deformed now, because the waveform is deformed because when you disconnect the battery voltage from this, whenever you disconnect it from the battery, it gives a different voltage. So now let me set up my scope properly. I'm doing 5 volts per division, so let me change my voltage, go to channel and change my voltage to, let's say, 1. Okay, then change this voltage also, so go to switch and change my voltage to 1. Okay, you can see it's reading abnormal, so let me do my trigger properly to get it reading properly. So now you can see the way the waveform is reading, and I'm measuring up to 2.5 volt and also 2.5 volts here. And let me check on my you can see I'm measuring 1.3 1.8. so this is a line that you can use to check signal 5 volt signals like injector pressure sensors. So injector pressure sensor is direct or indirect port injection. You can use it to check. So when you connect it, so the moment I connect the battery, you can see my voltage goes up. When I disconnect it, it comes down. Thank you for watching. Subscribe to my channel for more videos.